All right, so just a quick review to help kind of introduce our topic. These are quadratic equations, and we're solving them, right? We've gone over two different ways to solve them. One is by factoring. So if I'm going to factor, I want everything on one side, so I'd move the 16 over. So I have x squared minus 10x plus 16 equals 0. Okay, we factor that. We end up with x and what, minus 2 and minus 8. Then I set those factors equal to 0. So I got one of my solutions is x equals 2. My other factor is x minus 8. I solve that one and I get 8. So that's one way we can solve this by factoring. In the last lesson, we went through solving using the square root method. So I minus the 4 over. I get the x squared by itself. Take the square root of both sides. Don't forget the plus or minus. So x equals plus or minus the square root of 8. Square root of 8 is an irrational number. So we could simplify it. Let's see, 8 breaks apart to be 2 and 4 and 2 and 2. I've got a pair of 2's. So I end up with x equals plus or minus 2 square root of 2. I could also plug that in a calculator and get an approximate, right? So those are two different ways to solve. I want you really quick, pause the video for just a second, and try solving this equation right here. X squared plus 8x minus 11 equals 0. All right, hopefully you realized pretty quickly, didn't take too long, this does not factor. Like if I try factoring, factors of negative 11 that equal 8. Well, the only two factors are negative 11 and 1, or negative 1 and 11, but those don't add up to be 8. So it doesn't factor. You also can't do the square root method, right? We talked about if you've got an x squared and you have another x, the square root method doesn't work either. So none of the methods we've learned up until now work. And so we're going to go through a third method today of solving a quadratic equation. Before we do, though, I want to remind you of something. Write down this equation. We did these also in the last lesson. Let me change it just a little bit, actually. Let's write down this one. Let's go. X plus 4 squared equals, let's make it 27. So if I wanted to solve this equation, we can do square root method with this one, right? All I do is I want to get rid of the square first. So I take the square root of both sides. X plus 4 equals plus or minus the square root of 27. Minus the 4 over. So x equals negative 4 plus or minus the square root of 27. Square root of 27 is an irrational number, so it does simplify. Or we break it apart, it's 3 and 9, 3 and 3. All right, so we end up with a 3 on the outside. So really I have two answers, right? I have negative 4 plus 3 square root of 3. That's the exact answer. Or I have negative 4 minus 3 square root of 3. We could plug that in a calculator and get an approximate also. I wanted to remind you of that because that's going to be important here. So on this first example, why don't you just watch? What I'm going to try to do is I can't factor and I can't use the square root method. So I'm going to try to take this equation, the x squared plus 8x minus 11, and I'm going to try to write it like that problem we just did. I'm going to try to write it as being a perfect square, as something times itself equals a number. And this is this new method we're going to go through today. So just watch on this first one. So if I add the 11 over, I want to get it out of the way. So I have x squared plus 8x plus, I'm going to leave a blank there. Then I have 11 over on the other side. Well, think back to when we went from standard form to vertex form. We had to complete the square. We had to make one of these perfect squares. Well, the way we did it is I take half the middle number and square it. If you remember doing that, I go 8 divided by 2 and square it. Well, 8 divided by 2 is 4. 4 squared is 16. I need to add a 16 right there. Well, if I add a 16 to the left side, I've changed the equation unless I add a 16 to the right side. And now I still have an equivalent equation. I have the same equation in a different form. This is now a perfect square, right? If I factor it the long way, it's x plus 4 and x plus 4, which is really just x plus 4 squared. Over on the right side, I've got 11 plus 16 was 27. Hey, well, when I get to here, we just solved that equation over here, right? So this is the type of equation we've already solved before. So this process is called completing the square. Really, the new part is taking the equation from this form right here, right, and changing it to this form down here because I know how to solve it once it's in that form. And that process is completing the square. It's really the same thing we did. It's just a little variation on the process we did when we went from vertex form of a quadratic function to standard form of from standard form to vertex form of a quadratic function. So the good news is, if we can make those connections, hopefully this will seem really familiar, and we just got to kind of put a couple different things we've learned. We've got to take those things and put it together. All right, what we're going to practice next is just the part with figuring out this number and doing the factoring. So we're going to just practice that first couple steps. All right, so in your notes there, if you want to write down these two examples. So again, we're not actually solving on these examples. We're just going to complete the square and then factor it. So put down that first example. I have x squared plus 6x. So at the end of it, just put a plus blank. And we have to figure out what number we have to add to make it a perfect square. Well, I take that middle number, 6, I divide it by 2, and I square it. Well, 6 divided by 2 is 3. 3 squared is 9. Okay, and then factor it. I know it's a perfect square, so we don't have to go through do two sets of parentheses and go through that long way of factoring. I'm just going to think backwards. So to get a perfect square, I know it's got to be x squared. You have to square x to get x squared, and you have to square 3 to get 9. And then if you remember, that sign right there determines if it's a plus or minus. Okay, so I had to add 9 to make it a perfect square, and then when I factor it, it comes out to be x plus 3 squared. Let's try this next one. So we've got x squared minus 9x plus blank. So first we're going to figure out what number would I have to add to make that a perfect square. This one's a little tricky because we have, it's not going to come out to be a whole number when I divide by 2. So I'm going to take the negative 9. I'm still going to divide by 2, but I'm just going to leave it like that. You could divide those and get a decimal, but it's just as easy to do as a fraction. So I'm just going to leave it as a fraction, and then I have to square it. Well, a negative 9 halves squared, if I square a negative, it's a positive. 9 squared is 81, and 2 squared is 4. So I have to add 81 over 4 to make that a perfect square. And then we're going to factor it. And the factoring seems tough, but if we just think backwards, like what did we square to get x squared? What did we square to get 81 over 4? Well, that answer is right here, right? So all I have to do, that's a minus 9 halves. So that number right there just comes from what I squared up there in order to get that. Okay, and we're done. So I had to add 81 fourths, and my factored form is x minus 9 halves squared. All right, I want you to try a couple of these. Why don't you try number 1, and then let's do number 3. So pause the video, try those two. So you're just going to figure out what number do I have to add to make it a perfect square, and then factor it. And then come back and we'll go through it together. All right, so on this first one, right, if I take half of 10 divided by 2 and square it, that's 5. 5 squared is 25. Okay, and then to factor it, we know it's a perfect square. I got to square x to get x squared. I square 5 to get 25, and there's a plus. On this one, this is one of those trickier ones because it's going to be a fraction. So plus what? Well, 7 divided by 2 is just 7 over 2. And square it, I get 49 over 4, is what I'd have to add to make that a perfect square, to complete the square. Okay, that means it's going to factor to be x and 7 halves. And it's a plus because there's a plus there. All right, if you know how to do that first step, that allows us now to get the equation in the form that's easy for us to solve. So let's actually go through one and actually solve an equation now. So write down this next example. We've got x squared minus 16x equals negative 15. And we want to solve by completing the square. All right, so we're going to start just by adding that 15 over. Oh, just kidding. Sorry, for a minute there I blanked. If I were solving by factoring, we want to add the 15 over. If I'm solving by completing the square, I want that 15 on the other side. My apologies. So we're going to leave it just like that. But just rewrite it and leave a space there. Okay, so we need to complete the square. So I take negative 16 divided by 2 and square. Now, in this case, negative 16 divided by 2 is just negative 8. And negative 8 squared is 64. So I need to add a 64 there. If I add 64 to the left side, I've changed the equation, unless I also add 64 to the right side. We have to do the same thing to both sides. Okay, this side over here is a perfect square. That's what we were trying to do. That's x. What do I square to get 64? That's that -8 or -8. Over on the right side, I add those together. -15 plus 64 is 49. Okay, now once you get to here, you just need to stop. We know how to solve this. Like from this point on, we solved equations like this in the last lesson. I just take the square root to get rid of the square. When I do that, don't forget to put the plus or minus. So plus or minus the square root of 49, which is 7. Okay, finish solving for x, so I'm going to add the 8 over. So x equals 8 plus or minus 7. Well, 8 plus 7 is 15. And 8 minus 7 is 1. There's my two solutions right there, 15 and 1. Okay, so that's the process. Let me write down this one. I'm going to do the first step with you, and then I'll let you try this. You can pause the video, try it, and see if we've got it. All right, so it's that 2x squared plus 20x minus 8 equals 0. This one's a little bit different. If you have a leading coefficient, you cannot complete the square. So before I do anything, I have to get rid of that too. It works out nice because this is an equation. If you remember back when we went from standard to vertex form, we had to factor the 2 out. It's actually a little bit easier when there's an equation, because what I can do is I can just take both sides of the equation and just divide by 2 on both sides. When I do that, make sure you divide each term by 2. So 2x squared divided by 2 is just x squared. 20x divided by 2 is 10x, and a minus 8 divided by 2 is a minus 4. Over on the other side, 0 divided by 2 is still just 0. So if you do have a leading coefficient, right, like that 2 right there, you need to divide by that leading coefficient at the very beginning just to get rid of it. Okay, I want you to pause the video now that we've got rid of the 2. Pause the video and solve this one by completing the square, and then come back and we'll go through it together. All right, so we take the x squared and the 10x. We want them together. We move the 4 to the other side. So it was a minus 4, now it becomes a plus 4. And don't forget, whatever I add to the left side, I have to add to the right side. Okay, complete the square. So I take half of 10, which is 5, and I square it, so I get 25 there. Make sure you add 25 to the other side. Okay, we can factor this now. We got an x, and what do I square to get 25? And there's a plus. On the right side, I add those together. 4 plus 25 is 29. Okay, now I've completed the square. I have it now in a form where I can solve easily. So get rid of the square by taking the square root. X plus 5 equals plus or minus the square root of 29. Minus the 5 over, it's a plus 5. So when I move that over there, I have to minus it, so it becomes negative 5 plus or minus the square root of 29. Now, if we could keep going, we should. Square root of 29 is irrational, so I can't just plug in a calculator or whatever without approximating. And it doesn't simplify. Like, I can't break 29 apart. So that's my answer. Remember, it is 2 answers. My first answer is negative 5 plus the square root of 29. My second answer is negative 5 minus the square root of 29. Okay, let's just do one more. I want you to try one more, and if we've got it, we're good to go. So I'm going to have you do number 6. So pause the video, try number 6, and I'll go through it with you. All right, so the first thing, you can't have the 3 there. So the first thing we're going to do is divide by 3. I have to divide that side by 3. So over here I get g squared minus 24 divided by 3 is 8. Plus 27 divided by 3 is 9. And 0 divided by 3 is still 0. I want the 9 out of the way, so I'm going to move it over. G squared minus 8g plus something equals negative 9. Okay, figure out what goes there. So I take half of negative 8 and square it. That'd be negative 4. So that's plus 16. I have to add 16 to this side too. Don't forget that. This side is now a perfect square. So I get g minus 4 squared. Add those together, which is 7. Finish solving. Square root both sides. G minus 4 equals plus or minus the square root of 7. Add that 4 over. g equals 4 plus or minus the square root of 7. And if you could keep going, we should, right? If square root of 7, though, is irrational and it doesn't simplify, so that's really as far as I can go. So my two answers are 4 plus the square root of 7 and 4 minus the square root of 7. Okay, so that's solving a quadratic by completing the square. A nice thing about this method is it works on every single problem. So factoring only works if the quadratic factors. Square root method only works if you have the squared term and not the other x term. This method works on all of them. So you can always solve this way. It may not always be the easiest or the fastest way, but it always works. All right, good luck.